Hello everyone. Today we're going to talk about the relationship between work done and kinetic energy. As you may know that kinetic energy is the energy possessed by a moving object. So if you have an object that is moving, the energy that it possesses is kinetic energy. Work done is defined as the product of force and the distance moved in the direction of the force. Work done, or simply work, is equal to force multiplied by the distance moved in the direction of the force. Okay, so for work done, I can represent it with W is equals to force, I can represent it with F multiplied by distance, I can represent it with S. And from Newton's second law of motion, I know that force is equals to mass times acceleration. Okay, and from our studies on the equation of linear motion, if a body is having a uniform acceleration and it has change in velocities, okay, we know that we have an equation v squared is equals to u squared plus 2as. That is, the final velocity squared is equals to the initial velocity squared plus 2 multiplied by the acceleration multiplied by the distance. Then I can make S the subject of the formula by saying v squared minus u squared is equals to 2as. So if I should divide both sides by 2a, then I will be able to have S. Okay? So S, the distance, is equal to v squared minus u squared divided by 2a. I know F is equals to ma, and I know S is equal to v squared minus u squared over 2a. So I can be able to substitute that into this equation. So if work is equals to F times S, then work is equals to what is F? Is mass times acceleration multiplied by what is S. S is v squared minus u squared divided by 2a. Okay, so I can say ma into v squared minus u squared divided by 2a. So what can I do here? I can simply cancel acceleration. Okay, so what will I be left with? I will have m into v squared minus u squared divided by 2. Okay, so this can give me, if I should expand, I will have mv squared over 2 minus mu squared over 2. Okay, that's so we can also go further to say half mv squared minus half mu squared. From your study of mechanics, if you have half mv squared, you are talking about kinetic energy. That is kinetic energy. Okay, but in this circumstance, we have kinetic energy for the final velocity v and for the initial velocity u. So what can that tell us about a moving object? So simply, for a moving object, the work done is simply the change in kinetic energy. Okay, as you can see clearly from the equation, is the kinetic energy for the final velocity minus the kinetic energy for the initial velocity. So that simply tells us that for a moving object, the work done is equal to the change in kinetic energy. Okay, so if I should go and further simplify, I can have work done is equal to, since here half and m are common, okay, I can factorize that out to have half m. Then I will have v squared minus u squared. So work done is equals to half m v squared minus u squared. This can be our equation. Okay, so the equation that shows the relationship between kinetic energy and work done, we can just attach to the fact that work done is simply change in kinetic energy. Okay, moving on, we have a question here. It says the power required to accelerate a body of mass 900 kilograms from 64.8 kilometers per hour to 108 kilometers per hour is 864 watts. Calculate, question 1, the acceleration of the body, question 2, the distance traveled by the body. Okay, so we have a body that is accelerating from a velocity of 64.8 kilometers per hour to a velocity of 108 kilometers per hour. Okay, and it talks about power. Okay, so what we can understand from this is that first we need to establish the relationship between work done and kinetic energy, which we have derived the equation. Then we'll be able to solve this question. Okay, it's simple. So if I should collect the data, I know that the mass given is 900 kilograms. Okay, the power given is 864 watts. The initial velocity is 64.8 kilometers per hour. The final velocity is 108 kilometers per hour. Okay, so I'm having velocities in kilometers per hour, so I need to convert them in meters per second. So I know that, so for the initial velocity to be in meters per second, I will use the initial velocity in kilometers per hour. First multiply by 1000, then divide by 3600. So that will be 64.8 multiplied by 1000 divided by 3600. So what do I have? That will give me 18 meters per second. Okay, I'll do the same thing for the final velocity v. So that is final velocity v in meters per second will be equals to final velocity in kilometers per hour multiplied by 1000 divided by 3600. So that will be 108 multiplied by 1000 divided by 3600. That will give me that will be 30 meters per second. Okay, so moving on, I know the initial velocity, I know the final velocity. Okay, what can I do next? It says calculate the acceleration. All right, so we know that work done is equals to half m into v squared minus u squared. We have derived this equation. So first I can find the work done, okay, because this information is already available. So that will be work done is equals to half multiplied by what is the mass is 900. What is the final velocity? 30. It will be 30 squared minus what is the initial velocity? 18. So it will be 18 squared. So that is supposed to give me 9. That's supposed to be 259,200 joules. Okay, 259,200 joules. Okay, so I know that simply power is equals to work done divided by time. So power is simply the rate of work done. That's the definition of power. If you are dividing anything by time, you're talking about rate. So what is power? Is the rate of work done. So power is equal to work done divided by time. In that case, power, we already have that. It's given the question. It is 864 watts. Okay, so that will be 864 is equals to what is the work done? That's 259,200 joules divided by what is the time? Let's just say t. If I cross multiply, I will have 864 t is equals to 259,200. So if I divide both sides by 864, both sides by 864, then I will have time as what? As 300 seconds. Okay, so I know that from linear equation v is equals to u plus at, then acceleration will be v minus u divided by t. So acceleration is equal, so what is the final velocity? Is 30 meters per second. What is the initial velocity? 18 meters per second. And what is the time? We're able to calculate the time as 300. Okay, so therefore acceleration will be 0.04 meters per second squared. Okay, we get that. So that's question 1. Okay, and question 2 ask us to calculate the distance s. So I know that v squared is equals to u squared plus 2as, then v squared minus u squared equals to 2as. If you divide both sides by 2a, both sides by 2a, you will have s. So s is simply v squared minus u squared divided by 2a. So s is equals to what is v? The final velocity is 30 squared, the initial velocity is 18 squared, divided by 2 into what is the acceleration? 0.04. So s is equal to 30 squared minus 18 squared divided by, so the distance is 7,200 meters. Okay, yeah, so the distance is 7,200 meters, or you can express it in kilometers as 7.2 kilometers by dividing it by 1,000. Okay, thank you very much.